In this video, we're going to look at another example of volumes of revolution using the washer method. The question here is to find the volume of a solid obtained by rotating the region bounded by the curves y equals sine x, y equals 2 sine x, and the lines x equals 0, x equals pi, y equals 0 about the x-axis. The first step, as usual, is to find the points of intersection. So we have y is equal to sine x, and we have y is equal to 2 sine x, and equating the y values, solving for x. Y equals y, we get sine x is equal to 2 sine x. Bring it all to one side, and we get sine x is equal to 0. Well, sine x equals 0 when x is 0, when x is equal to plus or minus pi, x is equal to plus or minus 2 pi. In general, x is equal to n pi, where n is any integer. But we're only interested in the interval x equals 0 and x equals pi. So we will only take the intersection points x equals 0 and x equals pi. Now we need to know the y value of intersection. So x equals 0. Let's plug it into y equals sine x. And we get y is equal to sine of 0, which is just 0. Let's write it down, sine of 0 equal to 0. So the values, the points of intersection, xy coordinate is 0, 0. X is 0, y is 0. Now let's plug in x equals pi into y equals 2 sine x. And we get y is equal to 2 sine pi. Sine of any multiple pi is 0. 2 times 0 is 0. So we get pi and 0. And these are intersection points. All right, now that we have the intersection point, let's sketch the bounded region and the typical washer. So when you're drawing y equals sine x, this is just a regular sine graph, and y equals 2 sine x has twice the amplitude, but goes through the same x-intercepts. So the most important part is defining the inner radius and outer radius, and this is a source of a very common mistake when students are writing a quiz or an exam. So it's very important that you get the right radii when you're doing this type of question. So let's ask ourselves, what is the outer radius? The outer radius is a distance from the axis of rotation to the farthest point on this vertical slice. So it's going to be, the outer radius is simply 2 sine x given by the y value, y equals 2 sine x. The inner radius is a distance from the axis of rotation, which is the x-axis, to the closest point on the vertical slice. So the inner radius is just sine x. And we have a typical washer here where we have radius is equal to sine x. That's radius inner, and radius outer is radius is equal to 2 sine x. All right, once we have defined the inner radius and the outer radius, we can set up the cross-sectional area of one of these washers and also the washer volumes, and set up a definite integral to compute the volume. So let's do that. We have the cross-sectional area, A of x, is equal to pi times radius outer squared minus radius inner squared. So A of x is equal to pi. The outer radius is given by 2 sine x all squared minus the inner radius, which is sine x all squared, and let's close the bracket. How about the washer volume? The washer volume is differential volume is equal to pi times 2 sine x all squared, outer radius squared, minus inner radius squared, times the width, which is dx, and the integral adds up the differential volume from 0 to pi, and the integral adds up these washers, and then we get the entire volume of the solid. Notice it's the inner radius that generates the hole in the middle. So you're really applying the disk method twice. Basically, you find when you do pi times outer radius squared, you're finding the volume of the disk that's generated when you revolve the outer radius. Then you subtract the volume that is generated by revolving the inner radius, the inner function that creates the inner radius, and the difference of the two, the outer volume minus the inner volume, gives you the volume of that washer. That's what we're basically doing. All right. So now we want to set up a definite integral and find the volume. Volume is equal to pi, integral from 0 to pi, x equals 0 to x equals pi. Outer radius is 2 sine x, all squared, minus inner radius is sine x, all squared, integrated with respect to x. Let's simplify the integrand. Volume is equal to pi, integral from 0 to pi. 2 sine x squared gives us 4 sine squared x. 4 sine x all squared, or written as sine squared x, minus sine squared x. Let's enclose this in brackets. Now 4 sine squared x minus 1 sine squared x is just going to be 3 sine squared x. That's going to be pi, integral from 0 to pi, 3 sine squared x dx. But 3 is a constant, it passes through the integral. So the volume is equal to 3 pi, integral from 0 to pi, sine squared x dx. This is a fairly easy trigonometric integral that we can solve by applying a half-angle trig identity. Sine squared x is equal to 1/2 1 minus cosine 2x. So volume is equal to 3 pi, integral from 0 to pi, sine squared x is 1/2 1 minus cosine 2x dx. 1/2 is a constant, passes through the integral, we get volume is equal to 3 pi divided by 2, integrate from 0 to pi, 1 minus cosine 2x dx. So what we have is volume is equal to 3 pi over 2, integral from 0 to pi, 1 minus cosine 2x. Let me clean this up. Cosine 2x dx. Now we're going to have to integrate cosine 2x. We're going to apply the U substitution method. So U sub, and we'll let U equals 2x, du is equal to 2 dx. So we have integral cosine of 2x dx. That's going to be integral cosine. 2x is a substitution u. And if we solve for dx, we get dx is equal to du divided by 2. Dividing by 2 both sides, the 2 cancels out. We get dx is equal to du over 2. 1/2 comes out, and we get integral cosine u du. And what is the antiderivative of cosine u? That's going to be 1/2. Antiderivative of cosine u is sine u plus c, and we get 1/2 sine of 2x plus c. So that's just a bit of review for the U substitution method. So the volume is going to be equal to 3 pi over 2 times the antiderivative of 1, reversing the power rule, we get x, and integral of cos of 2x, applying the U substitution, what we just did earlier, that's just going to be sine 2x divided by 2. And that's consistent with the result that we got here. And evaluated from 0 to pi. We're now going to apply the fundamental theorem of calculus to solve this. Put the upper limit in, plug in the upper limit minus the lower limit, solve, and we get a volume of revolution. But you have to do it very carefully. It's easy to make mistakes at any step in the procedure. Put pi in, the upper limit, pi minus sine of 2 pi divided by 2 minus, put 0 in, we get 0 minus 0 in for x minus sine of 0 divided by 2, close the bracket and close the outer bracket as well. Sine of any multiple of pi is 0. Sine of 0 is 0. If we simplify this, we're going to get volume is 3 pi over 2 times pi minus 0 plus 0. Well, that's just all zeros. So volume is going to be 3 pi squared divided by 2. If we decimalize this, we'll get for approximately 14.8 unit cubed as the volume of revolution. All right, thanks.